Good afternoon. Yeah, so we see again. Uh, hi, just today I would like to share my experience about how to migrate the billion records from the SQL to NoSQL. Use the PySpark on Google Cloud Platform Dataproc. Okay, okay. So just introduce a short briefly about myself. So yeah, my name is Phi. You can call me Phi. Yeah, I'm from Thailand, but based in Singapore. I work as the senior consulting engineer in MongoDB in Singapore. So specials like migration and try to work with the customer how to migrate, how to deliver the MongoDB solution to them. Okay, so I just wrote some book, my first international book, yeah, in Pack Publisher about the Azure pipeline in CI/CD. So yeah, okay. So the agenda today is about the business context. Is why we need to do migration and what the limitation because I know that you have like the idea in my mind that why we need to do this solution. So I have um, the problem statement for you. So like a business and the architecture, how to migrate the data from the SQL server, Microsoft SQL server into the MongoDB, and approach how to do that by continuous technique. Okay, okay. The challenging is about because of the in that time. Um, our customer try to migrate. They host everything on GCP. This is the limitation. What the challenging is about the limitation from the business perspective. So they need to move the mic in the MongoDB on cloud. If you know that MongoDB is free, it have like a two license, right? Normally it's about the open source. And another one is about the enterprise or run on cloud, which is you can select Google Cloud, AWS, or Azure. You can choose anyone in the MongoDB. And the next challenge is about the billion rows. They have a lot of collection, but normally we try to divide by, they have like 100 tables in SQL Server. And the focus one is called like a transaction. As you know, everyone have a transaction, right? So they have a lot of the data is allowed 1 billion record, which is like normalization already. So I try to move that. And the challenging that how to denormalization from the relational database into the NoSQL. This is something is not easy. Okay. And the challenging that try to find out how to do like a minimum downtime when you migrate from database A to B. Actually, from my experience, it cannot say no downtime because of when you move the data from A to B, you need to change your application, right? You need to change the network, you need to change the endpoint, anything need minimum changing, maybe millisecond, maybe small second, but it's like a minimum downtime at all. So this is the challenge. So this is something that uh, when we discuss about the challenging, then we just have like a web application 1 and application 2, which is try to migration. This is like a overview, try to migration data, like a continue move data. This is something like a to move continuous until they test everything and then mark the date that we would like to cut off and change everything to run on version 2. This is the overview that we talk about. This is the first time, the minimum downtime. The second, we try to denormalize. This is like a example. This is example. Like if you have an order, a lot of the order, maybe you keep like 5 years or 10 years, you need to talk about that, oh, how to move all the 10 year or 5 year, it depends. And normally when you create relational database, you imagine that they have the normalization, which is like a third number form. It means like a try to make the data unique, the data not duplicate into relational style. But when you move into the collection style or the data MongoDB schema design, you need to try to make a different way, which is one way is called like a embedded document model, which is try to merge together because of the philosophy of the MongoDB design is depend on application usage. What application usage mean about the read heavy or read normal or write heavy or write normal. This is like a main idea when you try to migrate the relational database into the NoSQL. You need to think about that, how to use the which schema design. We have a lot of the schema design, but the popular one is called embedded and reference. Reference is mean the relational. It's like a make relational, like a have a foreign key, like a primary key, but um, it's necessary. If you have necessary, you can do that, but I thought I can say that normally we try to use the embedding or reference depend on how application usage. This is the thing. And after we talk about the challenge, then we just see like a I propose the solution. The high level is like simple. Use the Google Cloud platform because of the customer need or something. If you get, we have a limitation by the user. We cannot change anything. Okay. And also this is the high level, right? And then if we move to this is in the detail. I use the Google Cloud platform, and then as you know, I'm thinking about how to migrate the data, and the customer uh, give you not not many options to try to migrate the data. That's why in that time I just choose something that I think how to migrate the data like a continuous and seem like a try to manage the massive the data and continue. So I thought, oh, maybe I think it's better if we use like a PySpark. But the Python Spark normally when you try to select the Google Cloud service that can run PySpark, they have many service, right? But I just select the one that I think they build the PySpark inside. PySpark is mean like a you can run parallel of the Python in the data processing in the same time. So that's one I pick up the GCP Dataproc, which is I use the PySpark inside, and then they provide a lot of the data, which is like a offline data, which is like a Excel, maybe Excel data. They have like a big table data that we try to merge into the third party here. So we will focus inside how to write some code in PySpark inside the Dataproc, and then BigQuery is store the sum of data for reference. We have the customer have already BigQuery is existing, and also the storage file. Why we need storage? Because of normally when we use the Dataproc is like a virtual machine, like a read only. We don't need normally we don't encourage everyone to upload the code Python code inside the Dataproc, which is like a VM, because you can like destroy and up again destroy. So I host all the file PySpark into Google Cloud storage, which is linked to the VM. So it means when we run the Dataproc, we read all the library, all the Python file from the storage, and then execute them to merge the data. So this is the summarize the pipeline. The pipeline that okay, we use the Google Cloud storage to host the Python file and library. We use the Dataproc like make the continuous running. Because of if you imagine if we have like maybe 1 million record and we try to move from 1 million into another database, normally we cannot move in one time because of if we move in one time, maybe the production one will get the slowly or get the cache of the RAM memory a lot. So that's why we try to divide by something that try to move a little bit, like a move like a chunk by chunk, move like a partition, and then we mark to do. So that's why it's like a continuous running all the time. And then we have a SQL server, and then the destination is a large GCP. We go to the diff dive. This is something that I just mock the data. If you have like information like this, the member order and order detail, which is relational database. So, and then also we try to use the data proc, which is have all the file. This is like a simulate. If you have more than 3 tables, you have to imagine how. And why I separate 2 files? Because of if you imagine for normally all the table will keep like a timestamp, right? Like a create timestamp, modify timestamp, and maybe some table will collect the delete timestamp. That means when you move the data, and later on you will know that they have some transaction that update. So normally we have to run like a initial first, and then we try to run another to try to make the changing to update the record. So this is something that I put in the proc. And also in the MongoDB side, we create a collection that try to tracking. Tracking is mean we try in this case, limitation in this case, we need to make sure that we have primary key as a auto incremental, like a auto number, like a 1 2 3 4 5, like a big integer. So that means we have the tracking, try to make something. If we move fail, it's not marked yet. And when try to keep run it again, it will know that where is the running number to continue to start. So this is something like a tracking data that I store. So this is like a continuous technique. And also this is like a component inside. And the next one, this is like a flow. I divide by flow instead of show the code. So this is like a workflow that I work with. I try to imagine that the first step, like we lead the last update into the tracking collection from the MongoDB, which is the first time maybe 0 because of it is only first time, right? After that, when we fail, we stamp, or maybe run like we read the next batch, and then stamp again, and then the technique is like a call itself is like a recursion because of the data proc is like a VM, right? The data proc is like a VM that have API. We run VM finish, like for example, I used to 51 time I read the 50,000 rows at a time. When finished, I call API itself to call VM itself again and run again into another next batch from the 50,000. So like a 50,000, and then maybe 50,000 one until 100,000, and then 100,000 one into 150,000, something like this. This is like a continuous recursion. I have a little bit of code show you. So that means it's like a read first and then read next batch from the SQL server, and then transform the data, which is the difficult task. Because at that time, I did not use like a Copilot to help me. So I just go to a lot of uh, the article or Stack Overflow to try to make and to learn how to mapping easily. Okay, so this is something that I do, and insert back and then update the primary key, the next primary, and then call API itself. This is something about the technical continuous workflow. And the next, this is something like a simulate that if you have like an order and order detail like this, you need to think about how to convert into the MongoDB data model, which is something like this. This is like a embedding. I call embedding because embedding is suitable for only order that have like a like a less than 200. This is my suggestion. If you do MongoDB collection and you try to embed that the order detail like a product order, so that means for embedded, I encourage to when you buy something, you have to limit to buy only unique product 200 only. More than that is can, but it's make performance is slowly when you query the data. So that's why this is one I recommend. This is something like that. And also when we read from SQL Server, I use this style, which is like a batch size. You can test first from the production or staging environment that you try to read, and then it's make like a not consume the memory much. You have to test first. So the batch size is like a number of the records that you retrieve from the SQL Server. And also I use the no lock. No lock is mean when you try to read, you read it's called like a read dirty. It mean no matter update right now, but we try to read without effect from the insert or the write data on the SQL Server. So it's like a no lock. So I just read every time and then just check like the next uh, record. Okay. Okay. And this is the part of the talk about the continuous migration. This is code in Python. So it's something that if you do that, that means you try to run dataproc and then run finish. It it seems like a call itself again and again. So this is something like a keep continuous to call this part. This is the issue that have limitation because of the dataproc is come from the PySpark, right? PySpark is really fast to run processing, only 50,000. That means when you see in the log file of the GCP, you can see very fast how to stop them, how to stop and checking. It cannot easily. That's why I use the trick to make sleep 10 seconds before to the next call itself. Or maybe you try something because of if you not do that, what can we do? We can use the API by Python to see monitoring how the state of the dataproc to run PySpark, and you can see it stay like a finish. You have to break immediately, but it's not easy like that. So that's why I just put the time delay like a 10 second. So this is something that I use for the main. A part of that is like how to transform the data. So if we go to how to call the dataproc to running. So this is something that you can run into command line for the GCP command line. You run like a command line of the G Cloud. You run G Cloud dataproc job submit, and then all the jar file, because of as you know, PySpark is like a Apache Spark, but you use the Python to call that to run. So that means you have to upload all the library into the cloud storage first, the jar file. And also I use the Python code here to call. So this is the technique how to call, and some trick that how to make the delay and to migrate the data. Limitation, because of when you do, you need to know the limitation. After I don't think that we don't like my solution is not perfect, but my solution is can keep continue to improve So we have to know the limitation for any software or any solution. The limitation is mean I don't recommend to do like a insert and update in the same time both application. I mean both version. I I I did not do that, and I not recommend for this solution. And then support only primary key as auto number only. That means if you use like a unique identifier, like a GUI, right? GUID to running duplicate is not suitable for this solution. And also we need the create and modify date time because of we have to check that when we start to migrate the first place and then the modified time is more than today or not. It's like a move update existing record in the same time. So this is one this is all the limitation for our solution. And this one, this is the our reference as I use this. Okay. And last but not least, before we end off this, I would like to uh, announce something that will happen in Thailand. Yeah, I'm an organizer team from PyCon Thailand in October, and then now it's open for the call proposal already. So please, welcome and join. Maybe if you have time, travel into Thailand in October and join the section. Yeah. So thank you ขอบคุณครับ
So thank you, Piti. We have some sudden change in our schedule, but we have some time for a question. So if you would like to ask Piti for some question, just please let me know and raise your hand.
I have one question. When do you launch the batch job to migrate? Is there any continuous write in the original source of the database as well? Or you have to freeze the source database, the SQL database, before executing the migration?
Okay, good question. Normally, I still not freeze or block any write data. So that means production still live, still keep live and insert everything. So that means SQL Server is live, still have the data, insert the data into SQL Server. In the same time, we try to move the data out into MongoDB. This is the ideal solution, and we propose and we execute this style. Yeah.
Thank you.
Thank you. Actually, 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 we just move until they try to have a, I mean, in the time they try to rewrite the program, right? So when they move the data until they mark the date that they would like to cut off, and also in that time they try to see how fast to move the data, movement all the data from SQL Server into, it's like a move. So that mean that's why we use the PySpark, because of we can increase the number of the record. Oh, they don't write another version because the limitation is you cannot run the version 2. You keep run version 1, but you keep move the data until yes, that's right. Yes, have some minimum downtime when we would like to cut off. Yeah, I think normally when you do like a synchronize smoothly, I think you have to minimum downtime to switch the application link or the URL link also in load balancer, something like that. You need to do that, right? So it's like a minimum downtime also.
Yeah.
Yeah, so from your flow, I noticed that your API kept calling itself. So I'm curious, why didn't you maybe use like a Spark structured streaming to just stream the data from the source to a destination rather than do it in a hybrid of batch and continuous mode?
Okay, the good question. Because of when I talk this one, everyone asks me because the limitation that they ask me to do that. Because honestly, if you have if you not limitation to like a selected the solution that they concern, I prefer to you use like a Kafka C2C sync is better, but or change stream is better than use do like I do that. But I no choice. That's why I come back. I try to think about how to make this solution work in limitation. This is the thing. Yeah.
Okay, so I think we can thank the speaker one more time.
Thank you.
And I just want to remind you that you can still ask the question to Piti through the Discord channel. Thank you.